So we've been talking about linear equations last time, and linear equations are fairly easy to solve. You combine your like terms, you move things around, and these graphs are linear. So when you look for a solution, when you're solving those equations, you have one solution. And that's because there's a line, and that's where it crosses the x-axis. It will only cross once. It can't cross the x-axis more than one time because this is a straight line. So now as we talk about quadratics, we need to talk about what they look like and the difference between a quadratic. So a quadratic equation is one that looks like a parabola. Okay, so you get something, and they're just not quite as simple to solve because there's more going on there. So let me show you 3 examples. So if you were going to solve, first of all, a linear equation, let's look at that. When you solve that linear equation, you're finding one value for it. You're looking for one value where if you plug in an x value, it's what the y value equals at that x value, right? So you're just looking at that one solution. Okay, now when we look at solving a quadratic, we have, most of the time, your quadratic will have 2 solutions. Okay, and the solutions will be where it crosses the x-axis, and that's what you can see. There's 2 places that it crosses the x-axis. Now what happens is sometimes the quadratic will touch one time, and it will have what's called a double root. It will go through the same point twice, and that means that it's just barely touching, and it's not actually, doesn't have 2 separate solutions. So you can have 2 solutions, you can have 1 solution. You can also have no solutions. So what happens, and we're going to look at an example of this, is sometimes when the parabola is too high or too low, it doesn't go through there, and then the solutions would be what are called complex numbers. They wouldn't be real numbers. And we're going to look at how to solve those as well today. So anyways, you also can have upside down parabolas. Okay, so this one, for instance, would have 2 solutions, here and here. Okay, so when you're dealing with a quadratic, which looks like a parabola, what does it look like visually? It looks like this. What does it look like algebraically? So now asking just here, if I want to know what the equation looks like, it would look like y equals ax, squared plus bx plus c. Okay, so what a quadratic actually means is that you have your highest power is a squared variable. Okay, so quadratic means that. Now it can have an x term in it as well, as long as the highest power is x squared, and it cannot, if b equals 0, it could just be just a number. So for example, some examples of quadratics could be y equals x squared minus 10x plus 3. Okay, it could also look like y equals 3x squared minus 7. It could also look like y equals let's say 4x squared minus x plus 1. And even if it just has a quadratic, if you just have 5x squared, if you just have that squared term, this is still considered a quadratic. Okay, so quadratic is when that power is x squared. So let's do. So when you're solving quadratics, it requires more skills. You'll need factoring, or the quadratic function, or what's called not the quadratic function, it's quadratic formula. The quadratic formula, or completing the square. Now we won't be going through the completing the square in this class, but that is another way, and there's actually other ways as well. But because of what's just on the test that we're getting ready for, we're not going to be doing completing the square. So we're going to focus mostly on factoring and quadratic formula. Okay, so let's look at an example. We've done some of these already, but this will give you, we're going to talk more about solutions and what those solutions mean as we get into this. So, it wants me to have this. Okay, so we have, for example, you're used to seeing something like x squared minus 3x minus 10 equals 0. This is in the form that you're used to seeing it. It has a leading coefficient of 1 on the x squared, and it is factorable, so you can factor it. So we've done a lot of practice of this in the factoring section. But now we're going to take this and we're going to actually say, okay, if this is x, and this is x because x times x equals x squared, and we're looking for two numbers that multiply together to give us negative 10, and that add together to give us negative 3. Okay, and this is something that you guys have done, but I want to make sure I just cover that quickly in here, but then we're going to move a little bit faster now. So we're looking for what multiplies to give you negative 10. So 2 and 5 can multiply to give you 10, 1 and 10. Because this has to add the same numbers to negative 3, we know it has to be 5 and 2, and it needs to be a negative 5 and a positive 2. Okay, now from this point, when something equals 0, what would make this statement true? When we look at this, we have two things multiplied to each other. But if one of them equals 0, the whole thing will equal 0 because you're multiplying. So if you multiply by 0, the whole thing equals 0. So therefore, if x minus 5 equals 0, this statement is true. Or if x plus 2 equals 0, this will also make this statement true. So that's why there's two solutions here. There's two ways that this can equal 0. So we look at it and we take and add 5 to both sides to find that x equals 5 is a solution and x equals negative 2 is a solution. Okay, so we're finding those solutions. These are the factors. These are solutions. Okay, so this up here, these are factors. And these are your solutions, okay? And it's funny, I mean, it's the same thing, essentially, but it's so that you know what you're being asked for and what you're looking at. It's important to understand that this is factored, these are in linear factors, and these are solutions, okay? As you get into some that have more solutions even than just a quadratic, maybe if you're factoring out a trinomial that is power of to the degree, 5th degree, you would have 5 roots, and as you go through, you find those linear factors, and then you'd have 5 solutions. Okay, so with a quadratic equation, you'll have 2 factors, and you will have 2 solutions. Now, like I said, sometimes those solutions are not real. So let's look at a situation where that is the case. Oops, I don't want to get rid of that. Okay, so looking at this initially, we think, oh, well, it looks like we can just factor it out. So we go to try and factor it, and we look for values that add to give you 2, and or add to give you negative 1 and multiply to give you 2. Well, we find out quickly that you can't have positive 2, would have to be 2 times 1, or negative 2 times negative 1. And neither of those values will give you a negative 1 when you add them together. Okay, so we're at a loss here. We can't do that way. But we do have the quadratic formula, which I know all of you know because we have reviewed it. I'm going to review it again. So you need to memorize that the quadratic formula will give you the solutions to any quadratic. That is the beauty of this equation, is that it works for even those easier ones. It totally works. So what you do is you sing out your song. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So now I'm going to make you sing it in class. But when you're at your home, now you have me officially singing it on a video, and you can work on practicing your song. Okay, so we have this, and it is actually extremely useful. So then we're going to take it, and we're going to solve this. So now looking at this, we need to know what a, b, and c are. You need to have it in this form, where you have x squared, x, and a constant. A is the coefficient of x squared. In this case, it's 1. B is the coefficient of the x, which is negative 1. And c is your constant. Okay, now as you go to plug these values in, you sing your song again, x equals negative b. Now, b is already negative. So negative of negative b would be a positive 1, plus or minus square root b squared. Now, this is extremely important. If you are having problems with this, you need to listen very carefully. Your b value is in parentheses. So when you square that value, it doesn't matter if this is positive or negative. It will always come out positive when you square it because you are squaring the entire value. B squared minus 4ac all over 2a. Okay, now when you are simplifying this, I'm doing this more specifically because I see a lot of mistakes here. If you are not getting the correct answers on this is what you need to pay attention to. 1 plus or minus, now remember, this value has to come out positive because you are squaring it. So negative 1 squared is positive 1 minus. Now you are always going to take these three values and multiply them by each other because they're multiplied together where it is subtracted from this. A lot of people get confused and think this is a negative 4 and you're multiplying it, and that's where you get confused here. So this then would be 4 times 1 times 2, which is 8. So now we have, and then down the bottom, 2 times 1. So now we have 1 plus or minus the square root of 1 minus 8, which is negative 7, all over 2. Now this, you say, well, how can we take the square root of a negative number? You can't with real numbers. And so this is kind of an introduction. We're going to talk about this more in another section. But if you have a negative under a square root, it is an imaginary number. So you get your solutions here are complex numbers. Another way to write this, the square root of negative 1 is I. So you would write plus or minus the square root of 7i all over 2. Okay, so these would be your solutions, and they are complex numbers. So it's okay to get complex numbers. It's okay not to get whole numbers, and I would let you leave it in this form. Actually, for this section, I would even let you leave it in this form because we haven't talked about imaginary numbers yet. Okay? Okay, so the last example we're going to talk about is just another quadratic equation, but we're going to talk about getting it in the form that you need it in. So when we have something like this, 2x squared plus 3x equals 4 minus x. And let's actually do, let's do minus x squared plus x. Okay, so we get something like this. This is technically a quadratic, right? Because you look at it, the highest power is x squared, even though there's more than one x squared value. So we go and we put it into the form that we need it in to use the quadratic formula, which we need it in the form ax squared plus bx plus c equals 0. So when we go to put that in that form, we're going to rearrange everything here. So I'm going to first add x squared to both sides. So I add x squared, so I'll get 3x squared. And I'm also, so that canceled out this, I'm also going to subtract an x. So then I'll get plus 2x. And I need to subtract 4 from both sides because I am trying to eliminate everything so that I have equals 0. Okay, it's very important to use the quadratic formula. Now we go here and we look at it and we think, okay, we can try and start solving it with the 3x, so it does make it harder to solve it this way with setting your 2 parentheses. So I'm going to jump straight to quadratic formula and say, okay, my a value is 3, my b value is 2, and my c value is negative 4. Okay, so I go through x equals negative b plus or minus square root b squared, which b is 2 squared, minus 4ac. Make sure that the square root is over everything, all over 2a. Okay, so now we go through. Remember our simplification process. You start with leaving your negative 2 and your plus or minus alone. Under your square root, square this value, minus, and multiply all these together. So we have 4 times 4 times 3, which is 4 times 4 times 3 gives us 48. Okay, all over 6. So then the next step is now to simplify underneath that with our subtraction. So then we're going to take, and underneath this, we now have 4 minus a 48, which would give us a negative 44. Which I think I wanted this one to come out as a real number, but that's okay. And then over here we'll have over 6. Okay, so here, when you get that negative, I'm going to let you finish at that point. Okay. We've done some others with quadratic formulas that come out as whole numbers. Let's do a very quick one to make sure that you understand what happens. So let's say you have x equals negative b plus or minus the square root of 16 over 3. Okay, so I'm solving this, and I've gotten to this point. Then I would have 2 plus or minus the square root of 16 is 4 divided by 3. At this point, once you've gotten rid of everything, you do need to separate it out and do 1 as a plus and 1 as a minus. So you'll have 2 plus 4 over 3, and you will also have 2 minus 4 over 3. So this will give us 6 over 3, which is equal to 2, and this one will give us negative 2 over 3. So your solutions would be negative 2/3 and 2. Okay, this is another review day for those quadratics, and then we'll get into, we're going to review next time quadratics inequalities.